Okay. First question for you guys. We are supposed to factor this. What's the first thing I need to look for when I factor? GCF, absolutely correct. We're going to look for GCF first. Is there a GCF here? Is there a GCF here? No, there is no GCF. Technically speaking, because this comes up all the time, one will go into all of those, but we don't count one as a GCF because if I take a one out of each piece, nothing changes. Everything stays exactly the same. So that's why we don't count one as a GCF there. All right, then my second question is, can I use my shortcut? For those of you that didn't have me last semester, the shortcut is where we can get away with just using the X and we don't have to do the whole area model. Oh, I'm getting some no's on that, which I agree with. Why can I not use the shortcut? A isn't 1, absolutely correct. Because A does not equal 1. I'm going to go up here and label these. We've got our A value. I realize that our variable is also called A, but these terms have names. This is our A term, our B term, and our C term right here. And if this number in front of the squared variable is not 1, can't use our shortcut. So we're going to have to use the X and the area model, the box. So I'm going to draw my X first, and then I'm going to draw my area model. That's what I call the box, because it works off of the same principles for how you know to find the area of a rectangle, length times width. Okay, X first. Oh, no, we're going to fill in the parts of our area model that we can fill in first. What do I put up here in the upper left? What needs to go up there? 3a squared, absolutely correct. This is where I put my A term. What goes down here in the lower right? 4. Yes, this is where we put our C term. Fill those pieces in first before you use the X. All right, now over here on the X, we're going to multiply those two numbers together. When we're working in the X, we don't have any variables in it at all. I just want numbers. So I'm going to multiply the 3 and the 4 together. What do I get when I multiply 3 and 4 together? 12. Yep. And then down on the bottom, I put my B term. What is my B term? 8. Lovely. So we need to come up with two numbers, the numbers that are going to go right here and right here, that when I multiply them together, I get 12. But when I take the same two numbers and I add them, I get 8. What numbers will multiply to 12 and add to 8? 6 and 2. Nice work. Okay, so 6 and 2, we're going to put these into our area model. Now, when we go put them in our area model, I have to make sure to include something with it. What needs to go with the 6 and needs to go with the 2 when I put them over here in the box? A. Because these two combined together give me that B term, because my box represents my original problem. I've got the 3a squared. I've got the 4 from my original problem. I need that 8a. And when I put these two together, when I put 6a and 2a together, when we put things together in math, that always means to add. When I put those together, I get the 8a. So this area model, this box, represents exactly what I had in my original problem. All right, now we're going to pull it apart. We're going to factor it. We're looking for GCFs, only 2 boxes at a time. So I'm going to start off by looking at these top 2 boxes. What is the GCF there? A. A is the only thing that those 2 have in common. Okay, now let's come down here to the bottom 2 boxes. It doesn't matter where you start. You only want to look at 2 boxes at a time though, and we don't go diagonal. What goes into the bottom 2 boxes? 2. Is that going to be a positive 2 or a negative 2? Positive 2. And we know it's going to be positive because we look at the box that it's touching. This is touching the 6a box. If that's positive, then the sign that we pull out is positive. All right, we did the top 2, we did the bottom 2. Now I need to do the left 2 and the right 2. So here's the left 2 boxes. I need the GCF, the biggest thing that those 2 have in common. 3a, nice work. And now the right 2 boxes, 2a and 4. Those have a 2 in common. Is that going to be a positive 2 or a negative 2? Positive 2. Again, we look at the box that it's touching. That 2a right there is a positive 2a. So we're going to take out a positive there. So what are my factors of 3a squared plus 8a plus 4? What are my factors of 3a squared plus 8a plus 4? (3a plus 2 is one of my factors. And a plus 2 is the other factor. We only have 2 factors for this one. Very, very nicely done. Okay, we are going to jump back into where we left off yesterday with some scatter plot stuff. And then we're going to talk about graphing systems of linear equations. So we're going to be working with quite a few lines today. Okay, I have this scatter plot right here. This scatter plot shows a company's ice cream sales, which they're using the variable D to mean dollars for ice cream sales, and the high temperature outside. They're using T to mean the temperature, and they're measuring the temperature in Celsius. So this must not be here in the US. The data below was collected on 12 different days. So how much they sold and what the temperature outside was, the high temperature outside. Does anybody know what we call this line right back here? Does anybody want to take a guess at what we call that line? It is a positive line, but this specific line, when we have a line on top of a scatter plot, it has a special name. It's up there in the text. It's on the screen. This type of a line on a scatter plot, has a special name. And it's up on the screen right now. That's one of the things that we're going to identify about it. We will be identifying the slope. Look a little bit higher on the screen. Oh, so close. So close, so close. Look at the last sentence in the paragraph. It's at the beginning of the last sentence of the paragraph. Ooh, I like that comment. The data itself are all these individual points that I'm going over with blue right now. Each dot here is a piece of data. Best fit line. There we go. This is the line of best fit. This is the linear model that most closely represents the data. The data there is not a perfect line. When you plot all those dots from every day that they collected data, they don't line up and make a perfect line. But it kind of looks like a line. So a line can help this business make predictions about the future so that they can make sure to have the right number of employees on hand. Anytime we have a line, we're going to have an equation for that line. This right here is the equation for the line of best fit. This is the line that we see graphed right here. What is the slope for that line? I'm looking for a number right now. What is the slope for that line? Good guess. It's written in this form, y equals mx plus b, 33. Yes. Remember, this part of the equation is my y-intercept, and this part of the equation is going to be my slope. So I'm looking for the number that's next to a variable. I'm looking for the number that's next to the variable that's on the x-axis. And on the x-axis, they have temperature, and they're using the variable T to mean temperature. So that means that this right here is my slope. I'm going to write 33 here. What is the meaning of the slope? This, I want to make sure you guys in your own notes, in your notebooks, you need to have the equation for the line of best fit. And I want you to write down the meaning of the slope. You don't have to recopy that scatter plot, but I do want to make sure that you can go back and talk about the meaning of the line of best fit here. So when we talk about slope, don't even look at the line of best fit right now. When we talk about slope, slope is what over what? I'm looking for two words. Slope is what over what? And they both start with R. Rise over run, yes. Okay, we said our slope here was 33. 33 is a whole number, but if I'm going to talk about it as rise over run, I need it to be a fraction. How can I write 33 as a fraction? Absolutely, we can put it over 1. So 33 over 1. So here's my rise. And here's my run. So if I wanted to plot some more points on this line of best fit, would I go up or down for the rise? I would go up. So would we call that an increase or a decrease? An increase. Okay, so when we're talking about the meaning of the slope here, I'm going to start with that. I'm going to remember that slope means rise over run. I'm going to take my slope and I'm going to write it as a fraction. If I would go up because of my slope, then I'm going to say that this is an increase. An increase, well, since it's coming from my line of best fit, I actually need to start off with the word predicted. Because remember, each of those dots is the reported data. The line of best fit helps me make predictions. This is the predicted increase of, how much would we go up? What is that numerator? If I was at 33, what are we measuring on the y-axis? As I go up, what's changing? What is the y-axis measuring? Sales. Yes. And we're measuring our sales in dollars. So predicted increase of $33 for each, or for every, or per. Those are some of your key words to tell you when you're reading a story problem that you're looking at the slope. So predicted increase of $33 for each. Now I'm going to look at the denominator. That for each tells me I'm looking at a fraction. Down in the denominator is my run. Which way would we be running, left or right? We'd be running to the right. So would that be an increase or a decrease if I'm going to the right on the x-axis? Increase. Predicted increase of $33 for each one. What are we measuring down on the bottom? Temperature. And they're measuring the temperature in Celsius. So for each 1 degree Celsius increase in temperature, that is what our slope is telling us. Since this is a model for real data, it's a line of best fit, and my data doesn't all perfectly land on the line. That's why we're saying it's a prediction. Since I'm going up to the right, those are both increases. So I need to say how much I'm going up by. I need to say how far to the right I'm going. And then I need to have the meanings for the rise, the y-axis. And I need to have the meaning for the x's, the x-axis down there for the run. All right, I want to take this idea right here. We talked about slope. I want to answer a couple more questions about this exact same scatter plot. So let me recopy some of what I've got here because I like it. Okay, coming over here now. What is the y-intercept for this line of best fit? Again, I'm looking for a number. What is the y-intercept for the line of best fit? 84. Let's go. That is coming from right here. Here's my y-intercept. What is the meaning of the y-intercept for this situation? So I'm going to take that 84 and I want to write it as an ordered pair. What would the ordered pair look like for my y-intercept? What number comes first? What number comes second? 0, 84. Beautiful. This 0, is that in the spot or the Y spot? That's in the X spot. What are we measuring on the X axis in this graph? Temperature, yes. And so if the 0 is in the X spot, the 84 is in which spot? That's in the Y spot. And what are we measuring on the Y axis? Sales in dollars, yes. Okay, I know what each part of the ordered pair means. Now I can take this and I can write it as a sentence. So just like before, because this is coming from my line of best fit, this is a prediction. So this is predicted sales of $84 when the temperature outside is what? We predict that we're only going to sell $84 worth of ice cream when what is the high temperature? What's the rest of that ordered pair? 84 goes together with what number? 0. Predicted sales of $84 when the high temperature is 0 degrees Celsius. Beautiful. All right. We are now going to use this line of best fit to make some predictions ourselves. All right, so we're looking at the line of best fit equation. If I ever go too fast and you guys need me to go back a screen, please say something. So we are going to use the equation for the line of best fit, and we're going to make a prediction about what? What do we want to know about? What are we going to calculate? Excuse me. What do I want to know about? What do I want to calculate here? The temperature, yes. Calculate the high temperature. Which variable in that equation means the high temperature? T. So they're telling me to find T. Use the equation for the line of best fit to calculate the high temperature when the ice cream company sold $750. What are they telling me right there? How do I use that piece of information to answer the question? I'm going to put it in the place of T for temperature. Money. So it's going to go in the place of which variable? D for dollars. Sub in for D because that means dollars. Okay, so let's do that. 750 equals 33T plus 84. Now I need to solve this equation so that I can answer the question. What's the first thing I would need to do to be able to find T? Subtract 84 from both sides. I love it. What is 750 minus 84. Yep, 666. Ooh. What else do I need to do? Let's get rid of that. What else do I need to do to get T all alone? Divide both sides by 33. Yep. So 666 divided by 33. I'm going to have to round this. It doesn't come out to a nice whole pretty number. Do this on your calculators. You got a calculator on your computer, or you've got a calculator on your cell phone. We're going to round this out to about 2 places. Wonderful. 20.18. What kind of units should we put with that? Is that $20.18? Is that 20 customers? C. This is degrees Celsius. Right there. Fantastic. Fantastic. Okay. Similar idea to what we just did here. We're going to use that line of best fit. We're going to calculate something. So I have my equation. I want to use the equation for the line of best fit to calculate what this time? What am I wanting to calculate this time? T equals 27, yes. Temperature is 27, so we will sub 27 in for T. What are we trying to find? What is it that I want to know in this problem? Yes, D. Calculate the total sales. So they're telling me to find D, dollars. All right. So I'm going to have D equals 33. We're going to sub 27 in the place of T plus 84. Cool, cool, cool. What do I do first to answer this question? Multiplies. We're going to multiply 33 and 27 together. What do you get when you multiply 33 and 27? $891. D equals 891 plus 84. Now I need to add those two together. And I get what? 975. What kind of units should go with that? Do I do degrees again on this one? Dollars. This is dollars. Fantastic. Okay. I want to spend our last 10-ish minutes doing a little bit more practicing with graphing. We did graphing on the bell work yesterday. I'm going to give us some equations of lines, and you're going to practice graphing them. We're going to graph 2 lines on the same graph, and we're going to look for where they intersect. All right. So we're going to graph a linear system. We're going to graph each equation in slope-intercept form. So that is our y equals mx plus b form. And then we're going to look where the 2 lines intersect, and that will be our solution. When I look at the two equations they gave me, are either one of those in slope-intercept form already? And if so, tell me which one. The y equals equation, yep. So this top one right here is already in slope-intercept form. Let's go ahead and graph that one first. What's the first thing that I need to put on my graph? Where should my first dot go? 2. 2 anywhere? Do I put it here? Do I put it here? Do I like, what do you mean by put it on 2? There's a whole bunch of 2's on here. On the y-axis, there we go. 2 on the y-axis. So this is my y-intercept. So I'm going to graph it at 0, 2. Where do I go from here? I take this slope right here. I'm going to change it to be 5 over 1. And then what's it telling me if I change it to be 5 over 1? Remember, we said slope is what over what? Up 5 over 1. And when you say over, which over do I want to go? Right, because that's a positive. So up 5, right 1. 1, 2, 3, 4, 5, right 1. So right here. Can I fit any other points on this graph? Yes. Well, I can't go up 5 more or I run off the graph. How do I get more points? Down 5 and left 1. Down 5 and left 1. So I can get 2 more points on here. Then I can grab my straight edge, like your student ID, and I can draw through these points. I do want you guys to practice graphing. I know that if you don't have graph paper at home, that means you'll just be doing it on notebook paper. That's okay. On your first homework assignment, not the introduction video, because, well, that gets counted in the homework section. It's not actually a homework for this unit because it's not math. You are going to have to hand draw a graph for me. So I do want you guys to practice that. Okay, so there's my first graph. Is this bottom equation in slope-intercept form? No. How do I get it into slope-intercept form so that I can graph it? Get y by itself. So tell me how to do that. What do I need to do to the equation to get the y by itself? Minus x. I like that. So minus x, minus x. I'm going to have y equals, what comes after the equal sign? What does this need to look like? I could write it like that. Minus 4 minus x. So does that mean that this is my slope? No. Can you tell me another way to write this? I'm not going to erase it. What's another way to write this so that I see my slope right after the equal sign? Negative x minus 4. Either one of those ways of writing it is correct, but only the bottom one tells me the slope right at the beginning and has the y-intercept at the end. So here's my y-intercept. I'm going to go plot that point at 0, negative 4. So right down here. What is my slope? -1/1. Yes. This right here, -1/1 is our slope. So I have my rise. I have my run. Am I going up or down for the rise part? Down. We're going to go down 1, and then do we go left or right? Right. Okay, so from that y-intercept, I'm going to go down 1, right 1, down 1, right 1. Take it to the edge of the graph. Can I get more points on there? Yes, tell me how to get more points. Up 1, lift 1, shift everything backwards. Oh, when I do that, it hits my blue line right there. Grab my straight edge, draw this in. Okay, let's go. What is the solution for this graph, for this system of linear equations? What is the solution? I'm looking for an ordered pair. Close, that's part of it. Remember when we write an ordered pair? So I think you're looking right here. Does the x part or the y part come first? The x part comes first. So first from the origin, I'm looking, how far left or right did I move? We went left 1 to get to that point, and then down 3. Beautiful work. Let's start on the next one. I think we'll be able to get through it. And then we'll finish up talking about equations and inequalities tomorrow. Let's look at this real quick. Actually, I think we'll start there tomorrow because that was the bell right there. All right. We will pick up with the next graph tomorrow. We'll graph another system of inequalities, or sorry, system of equations, and then we'll also look at graphing some inequalities. I hope you guys have a fantastic rest of your day. You have a homework assignment that is due on Friday morning. You can go ahead and get started on it if you want to, but you do not need to. We'll keep talking about it tomorrow, and then it'll be due the next morning. Have a fantastic rest of your day, guys. I'll see you later.